Hi viewers, in this video we will solve problem 1.23 from the book Heat Transfer J.P. Holman 10th editions. A flat wall is exposed to environmental temperatures of 38 centigrade. The wall is covered with a layer of insulation that is 2.5 centimeter thick, whose thermal conductivity is 1.4 watt per meter centigrade, and the temperature of the wall on the inside of the insulation is 315 centigrade. The wall loses heat to the environment by convection. Compute the value of the convection's heat transfer coefficients that must be maintained on the outer surface of the insulations to ensure that the outer surface temperature does not exceed 41 centigrade. Okay, let me draw a simple schematic diagram for this problem statement 123. This is the wall. On this side we have provided the insulations. This is the insulation that is provided on this wall, so I will represent it by cross line so that we can differentiate from the wall and the insulations that is provided on the wall. Okay, let's come to the statement. Environmental temperature. So let's say this is the environmental temperature, that is T infinity, that is 38 centigrade. This is the temperature at inside of the insulation, that is Ti, and the temperature at the outside of the insulation, that is T naught. So what is Ti? That is 315 centigrade. And the temperature at the outside of the insulation, that is T naught, and that is 41 centigrade. So if you look at this, the heat transfer that is taken place in this insulation, that is by conduction heat transfer. The thickness of the insulation is X, and the thermal conductivity of this insulation is also given, that is 1.4 watt per meter centigrade. And what is the thickness of this insulation? That is 2.5 centimeter. So convert it into meter, just divide it with 100, so it will convert into meter, that is 0.025 meter. Okay, so the heat transfer that is taken place in this insulation, that is due to conductions. Now from this outside of insulation to the environment, the heat transfer is taken place by convections. So this heat transfers by conduction must be same to the convections. So the heat transfer in conduction case, that is occur inside the insulations, and the heat transfer in convections is the same. So in case of conductions, that is we use Fourier law of heat conduction, that is Ka, temperature difference divided by its thickness. And in case of convections, this is Newton law of cooling, that is H, A, and temperature difference. Okay, so this K, A, what is temperature difference in the conduction, that is Ti minus T naught, Ti minus T naught divided by X, and what is H that we need to find, then area, and then T naught minus T infinity. So this area is same with this area, so it will be cancelled out. Now put the values. It's very simple. The values of K is 1.4 multiply with the temperature difference, that is 315 minus 41 divided by thickness, that is 0.025. H we need to find, that is 41 minus 38. So upon simplifications you will get, so calculate this on the calculators. You will get the value, that is 15,344 equal to 3 times of convection heat transfer coefficient. To find the convection heat transfer coefficient, divide both sides 3. So you will get H, this 15,344 divided by 3, and you will get the convection heat transfer coefficient, that is 5114 watt per meter square centigrade. And this is the final answer, and that is the convection heat transfer coefficients in order to maintain the temperatures 41 centigrade at outside of the insulations. So this much convection heat transfer coefficient must be required, and this is our final answer. If you have any confusion, you can ask in the comment sections. I will respond accordingly. If you haven't subscribed my channel, please subscribe and share with ones who really need it. Thank you.